Hello everyone. Today we are going to discuss regarding the filtration process itself and the filtration unit in the water treatment plant. We have seen regarding the slow sand filter, but today we are going to see the rapid sand filter. Actually, filtration process and the disinfection process, these are the part of the unit number 3, but as the continuation of this treatment processes, we have seen the continuously this slow sand filter and rapid sand filter, and in the coming session we are going to see regarding the settling theory of the sedimentation tank. So uh, continuing with this rapid sand filter, if you see the basic difference between slow sand filter and rapid sand filter, it is quite clear from the name itself that rate of filtration it is more in the rapid sand filter. Otherwise, the components and the unit will be same. Only how it is maintained, how this rate rapid flow is maintained, that we are going to see. Also, we are going to see today regarding the how the backwashing is carried out, what formulation can be used in this filtration process, that we are going to study today. So rapid sand filter, if you see the essential features are enclosure tank, filter media, base material, under drainage system, appurtenances, various appurtenances are there. So as you can see, a filtration tank is there where you can find this water level, then this sand bed is there, then gravel bed is there, under drainage arrangement is there. So various walls are there and metering arrangement is there to measure the flow. So you can see on this side in the cross section, weir is provided, in between the venturimeter is provided, and also the clear water tank is there. So in detail we are going to study this. So enclosure tank, as it is a smaller in size, therefore can be placed under the roof, can be covered, rectangular shape, and constructed in the concrete or masonry. So these materials can be used for the construction. Depth of the this tank is generally 2.5 to 3.5 meter. Surface area 20 to 50 meter square. Length to breadth ratio is 1.25 to 1.35, and design filtration rate are 3000 to 6000 liters per square meter per hour. So this is more than the slow sand filter that we have seen earlier. Let's have the glance on the filter media. Now sand that should be free from dirt, organic matter, and other suspended solids. It should be hard and resistant to the even chemical actions. Depth of sand media 0.6 to 0.9 meter. Effective size 0.35 to 0.6 mm. Common value is 0.45. Uniformity coefficient Cu, that is 1.2 1.7. Common value is generally 1.5. Estimation of the depth. The depth of the sand bed should be such that the flock should not break through the sand bed. If the depth of the sand bed is less, remember the flocks will release from that, so that should be avoided. Depth varies from 60 to 90 centimeter. Minimum depth generally is given by the Hudson formula. The other formulations are there, which is Hudson formula gives Q multiplied by D cube multiplied by H divided by L is equal to BI into 29323, which is the empirical number, where Q is filtration rate in cubic meter per square meter per hour, assumed filtration rate multiplied by factor of safety. Then D, capital D, that is equal to sand size in mm. H is equal to terminal head loss in meter. L is equal to depth of sand bed in meter, and Bi is a breakthrough index, which is generally 4 into 10 raised to minus 4 to 6 into 10 raised to minus 3. So while carrying out the numerical examples, these concepts again will become more clear, but initially try to remember the terminology what we are going to use in this. Now what is base material? It is a gravel. Thickness of gravel bed is generally 45 to 60 centimeter. Now if you see the break up of this particular layer, so total depth you can see it is 60 centimeter is there. The size that goes on varying. So topmost layer of the gravel, that is a 15 centimeter. Size of the gravel, that may be 3 to 6 mm size. Intermediate 15 centimeter, 6 to 12 mm. Intermediate again 15 centimeter, 12 to 20 mm, and at the bottom 15 centimeter, 20 to 50 mm. Now estimation of the depth, to start with the size of gradation of 2 mm at top and 50 mm at bottom is assumed. The required depth L in centimeter of a component of a gravel layer of size D in mm can be computed by the following equation. L is equal to 2.54 into K into log D, where K can be taken as a 12 and D is the gravel size in mm. Okay, so this will be again clarified when we will discuss the regarding the numerical examples. Now this is also very important point under drainage system. Now why the under drainage system? What are the objectives of under drainage system? So the first one is to collect filtered water uniformly over the area of the gravel bed. It provides uniform distribution of backwater, wash water without disturbing or upsetting the gravel layer or filter media. Now if you see a pictorial view or isometric view of this, okay, this is a cast iron manifold at the center, right? These are the perforated pipes are there. Okay, so this is the bottom of this filter. Then these are the various layer. Gravel layer is there, then sand layer is there, and above that you can see the wash water troughs are there. Okay, and this total is a full of water. Now in the normal process, when the water is to be filtered, right? So that filtered water is taken from this perforated pipe itself, and which is taken from the bottom, right? As the water enters from one point, right, and get filtered from this perforated pipes, and from a central pipe drain is there, which is the where it is collected, all this. Then what will happen due to continuous use of filter? What is going to happen? Sand bed and the gravel bed, that is going to be clogged because of the clogs which are adhering with the surfaces. So after some time that will affect on the filtration rate. So to avoid that, the backwashing is carried out, and again by using the same system, because different walls are there that we are going to study today. So by using this wall, by using the same this arrangement, again wash water is you can say backwash water is supplied to these layers, and as the perforated pipes are there, so it will not disturb these particular layers, but it will wash this layer. And this wash water, which is a dirty water, you can say muddy water, so which is collected on this wash trough and is removed. So that process also we are going to see. Now apparent tendencies, as you can see, these are the wash water trap is there where this wash water or the muddy water is collected. Air compressors are required to supply the compressed air. Okay, then rate control devices, various valves are there to control all this. These are the various types of wash water traps are there. So depending upon the design, the arrangement of the wash water traps can be made. Okay, so that will be a central one, or that depends upon how the design is carried out and how the place is available. So, and also these are the different shapes of the wash water traps. Now again let's proceed further regarding the working of the rapid sand filter. So you can see here, uh, concentrate on this sand filter tank here. So this is the water level. Okay, while filtering, this is the water level. Now what are the various parts you can see here? You can, at bottom you can find out here this gravel, below that these perforated pipes are there. Okay, please concentrate on this. And these are the lateral drains which are perforated pipes, and this is the central drain, you can say, right? Above that the gravel layer is, gravel is there. Gravel, as we have discussed, that may be placed in a various layers as per the particle size. Similar thing is with the sand also. These are the wash water traps are they provided here at this position. Okay, that may be transferred to this. Then this is the inlet chamber. Okay, where the, you can see the influent, the water comes here. Then also we'll see regarding the what are the various walls are there. You can see wall A, wall B, wall C, wall D, okay, wall E and wall F is there. Okay, total 6 walls are there at present in this. That depends again how the facility you are providing there. Then compressor unit is provided here. You can see the compressed air can be given to this particular system, this perforated pipe system it is, right? At the same time, when you are supplying the compressed air, so this is a wash water storage tank. From this again, at a time you can supply this to wash air pipe, and this wash water is supplied to this, right? So when the washing is carried out, that because of that muddy water, this will be collected here, and by using this particular release valves, the water can be supplied to the wash water drain, right? So how this will function, that we are going to see what are the various types of valves are there. And you can see here, when this water comes here, it get filtered, right? And after filtration, through this, you can say this is the filtered water will be collected. Okay, so that will be passed through the here from the this wall B will be open, right? And that will be coming here. Okay, this is a filtered water storage tank. So let's move further. You can see this particular slide shows the position of the various walls. So here you are requested to concentrate what are the various walls are there. Wall A, can see it is a influent wall A, where from that water enters into the sand filter, right? Then second is the effluent wall B. Okay, you can see here this wall B is there here. That is the effluent wall, which is a filter wall, you can see. Then wall C for the carrying out the filtered water to drains. Now wall C, this particular wall C. Now what happens when you carry out backwashing? Directly after the backwashing, we are not supplying that water to the filtered water tank. For some time, what we are going to do, that this filtered water after the backwashing, for some time it is released through this wall C to the wash water drain, so that after some time what will happen, the proper filtration will take place, and the clear water then we can change the wall position, and then we can take it to there. Then you can, at that after some time, you can close the valve C and you can open the valve B here, and that will be, water will be taken here. Then wastewater valve D. Okay, you can see when the backwashing is carried out, what will happen? So because of this compressed air valve, which is wash water at valve E is there. Okay, you can see here this wash water, and this will be releasing the at the time there, and air valve F you can visualize here. So because of this, turbulence will take place, and the muddy water which is collected by this tank, right, and which is taken to the you can see what is given, the valve C is there. Okay, this water will taken by this valve C to the wash water drain. Okay, so very simple arrangement to understand. Now let's see how the working of the rapid sand filter takes place. All valves are kept closed except valve A and B. Okay, this valve A and B, these are open. Valve A is open to permit the water from clarifier, that we have seen. Then valve B is open to carry out the filter water to the this sump. Okay. So at a time valve A and B is open, so filtration takes place and the clear water comes here. Then head over the sand bed is 2 meter is maintained. Okay, the head of the water is maintained here. Desired filtration rate, this is 3000 to 6000 liters per square meter per hour. Filter run depends upon the quality of feed water. So backwashing, when you are going to carry out that, what is the duration, how you are going to adjust the filtration rate, that depends upon again the how you are going to get the quality of the feed water or the influent, you can say. Filter run may range between less than a day to several days. Objective of backwash is to remove accumulated particles on the surface and within the filter medium. Backwash is performed using wash water and air scouring. So that we have seen how it is carried out. Then what are the advantages and disadvantages of the rapid sand filter? Advantages are: deal with the raw water directly, occupies less space, filtration is rapid, washing of filter is easy, more flexibility in the operation. These are the various advantages are there. Then what are the disadvantages? Relatively high skill operation. During all these valve operations and to understand the backwashing process, it will require a skill. Okay, it is a costlier, the initial cost is more, and removal of the bacteria is 98 to 99%. Okay, then again this particular slide shows how a normal filtration goes on, and again how the process of backwashing takes place. Now you can see here, this is the filter media, this is water coming is here, this is the influent water. Now at present what is happening, the filtration is going to take, these are the layers which are filtering the water, these are the perforated pipe, and the filtered water is taken to the clear water supply tank, right. This is the under drain support. Now when the backwashing is carried out, what is done? Then it is done like this. You can see here this back flush supply is provided here. Now influent water is closed. Okay, this water to the filter water supply, it is valve is also closed. Now backwash supply is here. At a time here also what is happening? So with the water, even the compressed air is also separated. That because of this layers get turbulated, and because of that, so any kind of impurities there, that will be get washed, right, and that will be move towards this back wash water tubs are there. Okay, and which will taken out from to the central drain, you can say, of that wastewater drain, right. So this is very easy to understand what is a normal filtration processes and what is a backwash supply. Now during the backwashing, you can see here, this is the backwash water supply and which is taken out from here, right? Now regular bed and expanded bed when the washing is taken place. Okay, these 2 points we'll have to remember. So when the normal filtration is going to take place, the water moves like this, right? And in that case, the regular bed will be like this. But when the backwashing is take place, because of the turbulence, what will happen? This is the expanded bed and this is the total depth. So filter is backwashed when head loss through it has reached a maximum permissible. Okay, so what is head loss and how that can be understand that it has reached the maximum permissible, that we are going to see, right? Rapid sand filters are washed by sending air and water upwards through the bed by the reverse flow through the collector system. That also we have seen. Then 2% to 4% filter water is used for backwashing. So filter water also can be used for the backwashing purpose, so that the again clear water supply that becomes very easy. Now again let's have the glance on the steps on the backwashing. Close influent wall A. This wall A is closed. Close effluent wall B. This wall is also closed, right? So that there is no entry of the water in this there and no entry towards the filtered water storage. These two walls are closed. Open air wall F, so that air blows at the rate of 1 to 1.5 meter cube free air per minute per meter square of a bed area for about 2 to 3 minutes. This will break up the scum and lose the dirt. Regarding this wall F, this is opened, so it will make because of the free flow of air, so this scum layer will break, okay, and loosen the dirt. Remember, close the air wall F and open the wash water wall E gradually to prevent the dislodgement of finer gravel. Now close the air wall F. This wall F is closed and open the wash water E gradually, this particular. Okay, so what will happen? So this will be get washed. Okay, again continuing the same. Open the wastewater wall D to carry wash water to drain. Continue backwashing till wash water appears fairly clear. Now open wastewater wall D. Where is water? You can see this particular. So because of this turbulence given here and wash water, so this will come in the wash water trap and this wall D is opened. Wall D is opened and this is taken to the wash water drain. Close the wash water wall E. Close the wastewater wall D. Wait for some time till all matter in the bed settles down. Now again what we will have to do? Close wash water wall E. So where is wall E? You can see this particular. Now this supply of water, wash water wall, that will be stopped. Okay. Close the wastewater wall D. So because of this muddy water, so when it is becoming clear, more clear, this wall is closed. Then wait for some time so that the matter in the bed settles down. So this sand, this gravel, that settles down. Open wall A slightly. Open wall C for carrying out the filter water to a drain for some time. Wall A slightly open, that you can open the wall A, which is an influent wall, which will bring the water again here. But this time what we are doing? We are not opening this wall B. Okay. So what is the role of wall B? It takes the filtered water to the filter water storage tank. But at present we are not doing that. What we are doing? initially for some time we are going to keep the valve C open. So this filtered water will be initially for some time it will taken to the wash water drain, so that again if any muddy water is present or any dirt is present, so that will be taken to the wash water drain. Okay, then what is next? Close the valve C. Now we are going to close this valve C again and open valve B. Valve B is open now. Okay, open valve A completely. Now valve A is completely open, and to resume the normal filtration. Now the normal filtration will start. Okay, so very easy to understand and very interesting. Now this is, you can see these two figures, you can see this is in the case of backwashing, when the back wash water is in the operation, how the color of the water you can see, observe. And as the time processes, okay, again in the next you can see that color goes on decreasing. Okay, so this backwashing also the important operation in this, and that is a skilled operator is required for this. So today friends, we have seen regarding this rapid sand filter. So again in the coming session we are going to see regarding now settling theory in the sedimentation tank. Also we are going to see regarding the clariflocculator, and also we are going to see some part of the tube settlers or the plate settlers. So this thank you very much for joining today's session.